multiplying and dividing rational expressions. Our objective is to simplify rational expressions as well as multiply and divide rational expressions. Why learn this? You can simplify rational expressions to determine the probability of hitting an archery target. Recall, to write a fraction in simplest form, you can divide out common factors in the numerator and denominator. So say we had 9 over 24. That reduces to 8/3, and to do so we would divide the top by 3 and the bottom by 3. Well, that common factor is 3. So now let's try simplifying rational expressions. Alright, so in the first one we have 3x to the 7th over 2x to the 4th. Our 3 halves can't be reduced any further, so they're simply going to stay right where they are. We have x to the 7th and x to the 4th. That means in the numerator we have 7 x's, and in the denominator we have 4. Well, when we subtract 7 and 4, we end up with 3. So it's going to be x to the 3rd. There are more of them on top, so that's where you're going to leave them. This next one is a little bit trickier. To do this next one, we have to factor both the numerator and denominator. So, we want two numbers that multiply to give us -3, but when we add them, we get -2. Well, we would have 3 and 1, and since we want a -2, it's going to be a -3 and a +1 over, and now we want two numbers that multiply to give us 4, but when we add them, give us 5. So that would be a +1 and a +4. Notice how we have x plus 1 and x plus 1 both in the numerator and denominator. That means we can cross them out. So those are gone. We're factoring out this x plus 1, which leaves behind x minus 3 over x plus 4. Try these next three on your own. When you return to the video, the answer will be revealed. Alright, so in this first one, we simplified our numbers, which brought us to 2 over 1, and then we have x to the 11th over x squared, so when we reduce those, we end up with x to the 9th. In the second one, we can't do anything with the numerator. However, we can factor the denominator, leaving us with x plus 4, 3x plus 4 and x minus 1, canceling stuff out of our numerator and denominator, and we're left with 1 over x minus 1. In the denominator, or the second one here, the denominator, we can factor that as well as the numerator, unlike in B. So we have 2x plus 1 times 3x plus 2, and then we have 2x minus 3 times 3x plus 2. Our 3x plus 2, we can cancel those out, leaving us with 2x plus 1 over 2x minus 3. Now that you have our simplification down pat, let's go back. We're going to also now identify any x values for which the expression is undefined. So this is when we're going to look at what we have before we simplified. So we have 2x to the 4th. Now to make something undefined, this is when you have some sort of a number divided by 0. So what value of x is going to make this 0? Well, x cannot equal 0 in this. Let's look at B. So we had x plus 1 and x plus 4. So therefore, before we cross anything out here, we notice that x can't be equal to negative 1. So x cannot be equal to negative 1, and x cannot be equal to negative 4, because that would make it undefined. Now going back to the 3 you tried on your own, see if you can do the same thing. For which values are each of these going to be undefined? So in this first one, x cannot equal 0. And our second one, x cannot equal negative 4/3 or 1. And then the last one, x cannot equal 3/2 or negative 2/3. Alright, so now let's simplify by factoring negative 1. So to start, let's look at our denominator first. So we're going to simply factor x squared minus x minus 2, which will leave you with x minus 2 and x plus 1. So now if we look at our numerator, you'll notice that the only way to make either one of these happen is to factor out a negative x. So, or a negative 1x, if you will, because that's where that negative 1 comes in. So we're going to factor out a negative 1x. Well, what's that going to leave us with? So that leaves us with 2, negative 2, and then a positive x. You can rearrange this so it says x minus 2, because it's just a negative 2 and a positive x. Well, hey, those are the same, so we can cancel those out. So we can cross those out, leaving us with this negative 1x on the top with an x plus 1 in the denominator. Alright, so multiplying rational expressions. Factor all numerators and denominators completely. Divide out common factors of the numerators and denominators. Multiply numerators, then multiply denominators. Be sure the numerator and denominator have no common factors other than 1. So that will be needed for this next one. So we're going to multiply rational expressions. When you multiply fractions, you just multiply straight across. However, it might be faster if you simplify before you start multiplying. So this is when we can do something called cross-reduce. We've got, for example, we've got this x squared and this x squared here, so we're going to just get rid of that. So then, well, we have 3 and 15, so that's going to become 1, and this is going to become 5. And now we can do the same thing this direction. So we have y to the 5th and y squared. This y squared is going to be gone because it's smaller, and that only leaves you with 3 y's up here. So y to the 3rd, and then get rid of our x to the 3rd down here, which is going to leave you with just a simple 1x, or x squared. And now we can divide. We have 2, and this one becomes 4. So what are you left with? We're left with 5x, y to the 3rd on the top, and 1 times 4 on the bottom, which leaves you with 4. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed below. So hopefully you all noticed that the only way to do this one was to factor. The numerator here we can't factor any further, and the denominator we can. So we can factor out a 3, leaving us with x plus 4. And then we have a difference of 2 squares here, so we have x minus 2 and x plus 2. We can cancel out the x plus 2's. That leaves you with 1 over 3 times x minus 2, because remember we're multiplying. And then we can just distribute the 3, which leaves you with this. Alright, so now let's try looking at division. But first, recall that division is the same thing as multiplying by the reciprocal. So if this helps, leave it, change, and turn me over. Flip the second fraction and multiply. or multiply by the reciprocal. So you're essentially going to do the same thing you were doing here, only before you multiply, you need to flip the second equation and then multiply. So for this one here, for example, we're going to have 4x to the third over 9x squared y, and then to multiply, we're going to have 9y to the fifth over 16. Now it looks exactly like what we were doing before, so I want you guys to pause the video and try both of these on your own. When you return, the answer will be revealed below. Alright, so let's look at this first one now. We cross-reduced, leaving us with x to the third, y to the fourth over x squared times 4. We can keep reducing here because we have an x to the third over x squared. You could have done that here, or you could have done it back here when you see that you have x to the third on top with an x squared on the bottom. Either way, it's going to give you the same end result, which is this x y to the fourth over 4. In B, I understand this is not completely done. I wanted to pause here so that way you guys can see where things came from. So we have multiplied and flipped the second fraction here, and then we've factored each piece completely. So our numerator is factored to x to the third, and then we have x minus 2, x plus 2. Our denominator is x minus 2 and x plus 1. And then our numerator of our second one is x plus 1, x minus 1, and our denominator, x to the third, and then we have x minus 2, x plus 1. Once you have completely factored, notice how in this one here, I couldn't just stop by factoring out an x to the third. You had to completely factor, meaning this x squared minus 4 needed to be factored as well. Otherwise, this does not work. So once again, make sure you have completely factored before you start cross-reducing. So now that you have everything factored, you can cross-reduce. Something that I like to do when we have all these numbers is once we've finished cross-reducing, which are all of our pink marks here, I like to go back and circle what I have left just to make sure I didn't miss anything. And then I write my final answer. And there you have it. So we rewrote what we had left, and then we distributed, and we ended with our end result. Now let's try solving simple rational equations. Solving simple rational equations. Say that 10 times fast. Alright, so we want to solve. Check your solution. Just like we've done in the past, we want to start by factoring, and you want to factor completely. So this top is going to be x minus 3, x plus 3, and our denominator, well, we can't factor that. Alright, however, that means that we can now cross some things off to simplify, which leaves you with x minus 3 equals 7. So add 3 to both sides, and we end up with x equals 10. And to check, if we plug that 10 back in, we've got 10 squared minus 9, which leaves you with 91, and then you have 10 plus 3, which is 13. 91 divided by 13 is in fact 7, so we're good to go. Take a moment and pause the video and try B on your own. When you return to the video, the answer will be revealed below. Reminder, make sure you factor completely. Super important. And there you have it. We factored the top and we factored it completely. We simplified and then we solved. And that ends our video on multiplying and dividing rational expressions.